Good day, everyone. Today I'm going to discuss with you about inverse trigonometric functions. Please take note of this table. You need to familiarize yourself with the domain and range of the given inverse trigonometric function. Let us now find the exact value of the given inverse trigonometric functions. Arcsine of 1 or sine raised to negative 1 of 1. So there are two ways on how are we going to rewrite the given inverse trigonometric function. We can rewrite this as arc sine 1. That's just the same with sine raised to negative 1 of 1. Now to find arc sine 1, it's just simply, we can rewrite that as sine x is equal to 1, which implies that we're looking for the value of x, wherein we're looking for the given angle measure that satisfies the given equation. And the only angle measure that satisfies the given equation is x is equal to 90. Wherein, if we're going to transform this into radian measure, it will be, so we're going to multiply this by pi over 180 to transform this into radian measure. So it will be cancelled, it will be 1, and this will be 2. Therefore, the answer is pi over 2. As we can see, this is the range for arcsine. And it satisfies the range. It is because based on our illustration, y is greater than or equal to negative pi over 2, but less than or equal to pi over 2. Thus, it implies that it is within quadrant 4 to quadrant 1. So, or negative pi over 2, pi over 2 close. So as you can see, it is within the range, pi over 2. That's the reason why the final answer is pi over 2. Let's have another example. Sec arc sine 1 over 2. So we can rewrite, we're going to start answering the innermost, which is this one. So let's now find sine x is equal to 1 over 2. So we're going to take a look on or think of the value of x or the angle measure that satisfies the given equation. And the only um, angle measure that satisfies the given equation is x is equal to 30 degrees and x is equal to 150 degrees. Why? Because in sine 30 is equal to 1 half, also sine 150 is also 1 over 2. However, as we're going to take a look on our range falls only in quadrant 4 and quadrant 1. Therefore, 30 degrees falls in quadrant 1 while 150 degrees falls in quadrant 2. Therefore, our answer is only 30 degrees because 150 is not within our range. So therefore, our answer is x is equal to 30 degrees and then transforming we're going to transform that into radian measure on our final answer. So therefore, we're going to substitute. So instead of writing arc sine 1 over 2, we're going to write 30 degrees. So bring down sec and then 30. So we're going to find second 30 degrees. So based on our topic on week 3, which is all about circular function, second 30 degrees is equal to 2 square root of 3 over 2. 2 square root of 3 over 3. Okay, so therefore, our final answer is 2 square root of 3 over 3. Let's try another example. Cos arc sine of 1 over 2. So again, we already answered this one. Arc sine 1 over 2 is equal to 30 degrees. So let's bring down cosine. Cosine 30 degrees is equal to square root of 3 over 2. So therefore, our final answer is square root of 3 over 2. Next, we have sine arcsine of square root of 3 over 2. So let's now answer the innermost. So it will be sine x is equal to square root of 3 over 2. So we're going to take a look or think of angle measure that will satisfy the given equation. So for this one, The only angle measured that satisfies the given equation is x is equal to 60 degrees and 120 degrees. Like what I told you, we're going to take a look on our range for sine. Our range falls in quadrant 4 and quadrant 1. 60 degrees falls in quadrant 1, while 120 degrees falls in quadrant 2. Therefore, the only angle measure that will satisfy the range is 60 degrees. So therefore, our answer is 60 degrees. So let's bring down sine, and then we're going to bring down 60 degrees or substitute. So sine 60 degrees is equal to square root of 3 over 2. There are also conditions that for this one, for this given example, there is what they call rule. If we have example like this one, sine arcsine square root of 3 over 2, the answer is square root of 3 over 2. This one, this is the only answer. So it implies that if we have cos arccos x, the answer is x as long as x satisfies the given range. So if we have tan arctan x, the answer is x as long as x satisfies the given range. Let's try another example. Tan raised to negative 1 of 1, or we can say that arctan of 1. So we can write that as tan x is equal to 1. So it implies we're going to think of angle measure that will satisfy the given equation. So as we're going to take to look back on our topic in circular function, the angle measure that only satisfies the given equation is 45 degrees and 225 degrees. So if we're going to take a look on the range for tangent, the range falls in quadrant 4 and quadrant 1. 45 degrees falls in quadrant 1, while 225 degrees falls in quadrant 3. Therefore, the only angle measure that satisfies the equation is 45 degrees. So therefore, x is equal to 45 degrees, and we need to transform this into radian measures, so times pi over 180. So the answer is pi over 4. So the final answer is pi over 4. Let's try another example. Tan raised to negative 1 of negative square root of 3, or arctan negative square root of 3. So we're going to rewrite this as tan x is equal to negative square root of 3. So meaning we're going to think of angle measure that will satisfy the given equation. So the only angle measure that satisfies the given equation is x is equal to 120 degrees and x is equal to 300 degrees. Now, if we're going to take a look on the range for tangent, it falls in quadrant 4 and quadrant 1. So therefore, 120 degrees falls in quadrant 2, while 300 degrees falls in quadrant 4. So therefore, the answer is 300 degrees. However, if we're going to take a look on range, it follows negative pi over 2 to pi over 2. Therefore, what are we going to do? We're going to get the negative coterminal angles for x equals 300 degrees, and that is x is equal to negative 60 degrees. Now we're going to multiply this by pi over 180, and that is negative pi over 3. So therefore, the final answer for tan raised to negative 1, negative square root of 3, the answer is negative pi over 3. Next. Okay, let's try another example. Cos arctan negative 1. So we're going to start with the innermost arctan negative 1. So we can rewrite this as tan x equals negative 1. Meaning we're going to think of angle measure that will satisfy the given equation. So the only angle measure that satisfies the given equation is x is equal to 135 degrees and 315 degrees. However, if we're going to look on arctan, the range for arctan, it falls in quadrant 4 and quadrant 1. 135 degrees falls in quadrant 2, while 315 degrees falls in quadrant 4. So therefore, x is equal to 315 degrees. No need to transform this in the region measured because we still have cosine. So therefore, bring down cosine, and then the answer for arctan negative 1, which is 315 degrees. So cos 315 degrees is equal to square root of 2 over 2. So the answer is for cos arctan negative 1 is equal to square root of 2 over 2. Okay, let's try another example. Arccos sine negative pi over 6. So we're going to start with the innermost sine negative pi over 6. Negative pi over 6 just only negative 30 degrees. If we're going to take a look on the coterminal angle, positive measure coterminal with negative 30 degrees, that's 330 degrees. So we're going to look on the value of sine 330 degrees, and that's negative 1 over 2. So bring down arc cos, and then the value of sine negative pi over 6, which is negative 1 over 2. So we can rewrite arc cos negative 1 over 2 as cos x is equal to negative 1 over 2. So it implies that we're going to think of angle measure that will satisfy the given equation. So the angle measure that only satisfies the given equation is x is equal to 120 degrees and x is equal to 240 degrees. If we're going to look on range of arc cos, that falls from 0 to pi. Thus, it implies that the range of arc cos falls in quadrant 1 and quadrant 2. So now, 120 degrees falls in quadrant 2, while 240 degrees falls in quadrant 3. Therefore, the answer is 120 degrees because 240 degrees is not within the range of cosine. So therefore, the answer is 120 degrees. And then we need to transform this into region measure times pi over 180, which is equal to 2 pi over 3. So therefore, the answer is 2 pi over 3. Okay, let's try another example. Our cos 7 pi over 6. So let's start with the innermost, cos 7 pi over 6. Cos 7 pi over 6, 7 pi over 6 is equal to 210 degrees. And cos 210 degrees is equal to negative 1 over negative square root of 3 over 2. So let's bring down our cos. And then the value of cos 7 pi over 6, which is equal to negative square root of 3 over 2. So now, let's rewrite this as cos x is equal to negative square root of 3 over 2. So we're going to think of the angle measure that will satisfy the given equation. So the angle measure that only satisfies the given equation is x is equal to 150 degrees and x is equal to 210 degrees. If we're going to look on the range on cosine, it falls 0 to pi. So it falls in quadrant 1 and quadrant 2. So now 150 degrees falls in quadrant 2, while 210 degrees falls in quadrant 3. Therefore, the answer is 150 degrees. So x is equal to 150 degrees. Let's multiply this by pi over 180 to transform the degree measure into region measure, and that's equal to pi over 6. So therefore, the final answer is pi over 6. Let's try another example. Arctan tan pi over 4. So let's now start with the innermost tan pi over 4. Pi over 4 is equal to 225 degrees. And tan 225 degrees is equal to 1. So we're going to write arctan and the value of tan pi over 4, which is equal to 1. Arctan 1, so we can rewrite that as tan x is equal to 1. And we're going to think of the angle measure that will satisfy the given equation. The only angle measure that satisfies the given equation is 45 degrees and 225 degrees. If we're going to look on the range for tangent, it's negative pi over 2 from negative pi over 2 to pi over 2. So, therefore, it falls in quadrant 4 and quadrant 1. 45 degrees falls in quadrant 1, while 225 degrees falls in quadrant 3. Therefore, the answer is 45 degrees because 225 degrees is not within the range. So, therefore, x is equal to 45 degrees, and then transform this into region measure times pi over 180, it will be pi over 4. So, therefore, arctan pi over 4, the answer is equal to pi over 4. Let's try another example. Sine 2r cos negative 12 over 13. So it's just simply double angle formula. It's just simply sine 2a. So let's write first the formula for sine 2a. Sine 2a is equal to 2 sine a cos a. For this one, we already have the value for cos a. Cos a is this one. Cos a is equal to negative 12 over 13. So we can bring down 2 and then substitute cos a, which is equal to negative 12 over 13. So we need to get or find the value of sine a. So if cos a is equal to negative 12 over 13, we need to find sine a. So it means that the value of x is equal to 12 and the value of r, which is equal to 13. So we need to find the value of y because cos a is equal to x over r. So to find the value of y, we have r squared is equal to x squared plus y squared. By substitution property, it will be 13 squared is equal to 12 squared plus y squared. 13 squared is equal to 169 is equal to 144 plus y squared. 169 minus 144 is equal to y squared. And then it will be 25 equals y squared. Therefore, the value of y is equal to 5. So we can write that as 5 over 13. But what will be the sign? So since cosine is negative, if we're going to look on the range for cosine, this one, it is from quadrant 1 and quadrant 2. Cosine is only negative in quadrant 2 and not in quadrant 1 because in quadrant 1, cosine is positive. And cosine is negative for quadrant 2. Therefore, it falls in quadrant 2. And sine in quadrant 2 is positive. Therefore, sine A is equal to positive 5 over 13. Now, we're going to multiply 2 times 5 is 10 times negative 12, that's negative 120. 13 times 13 is 169. Therefore, the final answer is negative 120 over 169. Let's try another example. Cos 2 arcsin negative 4 over 5. It is just the same with cos 2a. So the formula for cos 2a is cos squared a minus sine squared a. Now we already have value for sine a. Sine a is equal to negative 4 over 5. So let's substitute. Instead of writing sine a, we're going to have negative 4 over 5 squared. Since sine a is equal to negative 4 over 5, we need to find cos a. So y is equal to 4 and r is equal to 5. So using r squared equals x squared plus y squared, r is equal to 5. So we have 5 squared equals to 4 squared plus y squared. 5 squared is equal to 25 equals 16 plus y squared. So we have 25 minus 16 equals y squared. We have 9 equals y squared, therefore y is equal to 3. So therefore we have 3 over 5. Now, we're going to look. Sine is negative a is equal to negative 4 over 5. As we can see or look on the value of the range, arcsine, the range falls in quadrant 4 and quadrant 1. Since sine is negative, therefore, sine is positive in quadrant 1. Therefore, it falls in quadrant 4. So, if angle measure falls in quadrant 4, cosine is positive in quadrant 4. Therefore, cos A is equal to positive 3 over 5. So, we have 3 over 5 squared. So, squaring both numerator and denominator, it will be 9 over 25 minus negative 4 over 5 squared is equal to 16 over 25. So, therefore, cos 2a is equal to negative 7 over 25. Let's try another example. Sine arcsine of square root of 3 over 2 plus arccos of 1 over 2. So, we're going to have sine a plus b. So, which is equal to sin cos cosine. And then we have AB. And then, since plus, we are going to use plus. So, we already have the value for sine A. Sine A is equal to square root of 3 over 2. For this one, cos B is equal to 1 over 2. So, we need to find cos A. And we need to find sine B. Now, if we have square root of 3 over 2, for cos A, using, we have value of y, which is square root of 3, and value of r, which is equal to 2. Using r squared equals x squared plus y squared, we can get the value of x, which is equal to 1. So therefore, cos A is equal to 1 over 2. For this one, we have x is equal to 1 and r is equal to 2. Using r squared equals x squared plus y squared, we can get the value of y, which is equal to square root of 3. Therefore, sin b is equal to square root of 3 over 2. So, by substitution property, we can now have, instead of writing sin A, we can write square root of 3 over 2, cos B, which is equal to 1 over 2, plus cos A, which is equal to 1 over 2, and sin B, which is equal to square root of 3 over 2. Multiplying that, we can have square root of 3 over 4 plus square root of 3 over 4. So therefore, we can have 2 square root of 3 over 4, and then simplifying this, it will be square root of 3 over 2. So our final answer is square root of 3 over 2. Let's try another example. Cos arcsine of 2/3 plus cos arccos square root of 3 over 2. So it's just simply cos A plus B, which is equal to cos, sin. So it's AB, and then since that's plus, we're going to use minus. So we have sine A, which is equal to 2/3. So therefore, we need to find cos A. So to find cos A, we have the value of y, which is 2, and value of r, which is 3. So if we're going to use the formula r squared equals x squared plus y squared, we have 3 squared equals 2 squared plus x squared. So we have 9 is equal to 4 plus x squared. So we have 5 is equal to x squared, so the value of x is equal to square root of 5. So therefore, cos A is equal to square root of 5 over 3. For this one, cos B is equal to square root of 3 over 2. So we need to find sine B. Again, we already find sine B for this one because x is equal to square root of 3 and r equals to 2. Using r squared equals x squared plus y squared, we have value of y, which is equal to 1. So therefore, it will be 1 over 2. Now, by substitution property, it will be cos A, which is equal to square root of 5 over 3, cos B, which is equal to square root of 3 over 2, minus sine A, which is equal to 2/3, times sine B, which is equal to 1 over 2. Square root of 5 times square root of 3 is equal to square root of 15 all over 6 minus 2 over 6. So therefore, the final answer is square root of 15 minus 2 all over 6. That's all. Thank you and happy math learning. Please don't forget to like our video and subscribe on our channel. God bless everyone.